This is the screencast for section 2.1, example 7. We're going to predict some maximum revenue. It says use the model y equals that, let's see, that's negative 15,358.93x plus 73,622.50 from example 3 to develop a model for weekly revenue generated by donut-shaped oat breakfast cereal sales. Determine the maximum revenue and how to achieve it. So a maximum implies that this graph is going to have to go from increasing to decreasing, which means I need some sort of parabolic shape like we are studying in this section. The equation we came up with in example 3, this y equals, the negative 15,000 thing, that represented the amount of boxes sold after, depending on the price per box. So our total revenue is going to be the price per box, which was X, times this Y value, meaning the number of boxes. So in other words, R equals X times this whole model that we came up with in example 3, negative 15,358.93x plus 73,622.50. So there's my x squared. Once I distribute that x, I have an x squared in my formula. To solve graphically, to find this maximum revenue, I put the formula into y1, and then I'm going to hit graph. I got to find this maximum. All I see right now is a vertical line at zoom 6. So I'm going to hit trace. And I'm guessing it's going to be way, out to the right. Now I watch my y values here as I trace, and I'm getting in the 80,000s. So I'm gonna change my window just so I can start to picture what this is like, and I'm going to change my y max to 100,000. Graph. Oh, so I do see this parabola. Now it looks like I can change my x min to like -2, and then my x max to 1, 2, 3, 4, 5, I don't know, maybe 7, just to get a good buffer for what's going on in the window. Okay, that's a good window. So I'm going to go second calc max, number 4. To find the maximum. And then back on my guess. So the maximum is 2.39, so almost 2.4, comma, 88,226.73. Well, now we need to interpret what that means. X stood for the price per box. So then the output here is going to be the total revenue made. So when the box costs $2.40, a total of 88,220, let's go with $7 will be made. The now try problem to go with example 7 is number 55, determining revenue. Well, this one already gives us a function. It says the per unit price P in dollars of a popular toy when X units in thousands are produced is modeled by the function. So basically, this is taking into account supply and demand. So if so many are produced, people are going to want it more. If there's less produced, etc. So the price P is 12 minus 0.025x. The revenue in thousands of dollars is the product of the price per unit and the number of units. So we have a total formula of x times 12 minus 0.025x, and we need to state the dimensions of the viewing window that shows a graph of the revenue model for producing 0 to 100,000 units. So my first step is to put that function in y1. x parentheses 12 minus 0.025x, close parentheses. I can already tell you that if we want to produce 0 to 100,000 units and x is units in thousands, I'm going to cross off the thousands part, and I'm going to change my x window, my x min and x max, to represent 0 to 100. I have no idea if my y max is going to be good or not. Let's look here. No. So I'm going to hit trace, and my y values are a little under 600, so I'm going to change my y max instead of to 100,000 from the last problem. I'm going to change it to 700. So state the dimensions of a viewing window that shows a graph of the revenue model producing 0 to 100 units. So I still need to see higher because I can't see the values all the way over to 100 units. So I'm going to change my y max to maybe 1,000. That's good. Now I can see the whole model all the way over to 100 units. Part B asks, how many units should be produced if the total revenue is to be $1 million? 1 million. Well, I'm not going to put 1 million into my y maximum because this problem made things more complicated than they should be. It says let's see, revenue in thousands of dollars. Again, in thousands. So I'm going to cross off 3 zeros. I'm actually going to enter in 1,000 into y2. So this 1,000 in y2 actually represents $1 million. It's like $1,000,000. $1 million. Again, more complicated than it needed to be. That's fine. So let's hit graph and see how the window is so far. Okay, so my horizontal line that I'm trying to find the intersection with the model is right at the top. I want to definitely go higher on my y max. I can also see that the intersection is going to be off to the right, so I want to go higher on my x max. So let's change the x max to 150. And let's change the y max to 1250. There. Now I can see the intersection. I can see where our model will actually hit the y value, $1 million, which is $1,000. So second calc, intersect, enter, enter, enter. I got the intersection is 107.34, comma 1,000. So this is 107,000 units because this is in thousands of units. So 107,000 units will produce $1 million.